Let's take a look at this example. Again, we have diodes in parallel with the resistor. So, what we're supposed to do first? We're supposed to always check if the diodes are going to be in the on state. Do not assume, because we have silicon and germanium in series, that we are going to have 1 volt across resistor R1. This is wrong way to start the problem. You're supposed to first ignore these two diodes and find the voltage across resistor R1. And if the voltage across resistor R1 is going to be greater than 1 volt, these two diodes are going to conducting, and the voltage across the resistor with the diodes connected to the circuit, right, is going to be 1 volt. But if the voltage across resistor R1 is less than 1 volt, the diodes are not going to work. So the voltage across the resistor R1, which you found, less than 1 volt, is going to be the same like you found, right? So what I mean by that? At the very first moment, we're supposed to forget about these two diodes. So just imagine that they do not exist. So basically we have just a simple series circuit. And what we're supposed to do, we're supposed to use voltage divider to find voltage across resistor R1. Okay? One more time, these two diodes are not existing at this moment, even if they are on the board, but imagine that they are not. So we have to find voltage across resistor 1. VR1 is equal voltage source times R1 over R1 plus R2. So I have voltage source 12 volts times R1 500 ohms over 500 ohms plus 5.2 kilo ohms. VR1 is equal 1.053 volts. Okay, so the voltage across the resistor is greater than 1 volt. Maybe not much, but is greater. So it theoretically, one can say that these two diodes are going to be in the on state. Okay, so they start to conduct. So if, right, VR1 is greater, right, than the voltage across these two diodes together, okay, greater than 1 volt, right, so VR1 is equal 1 volt. Okay, so what I mean by that, if you found from the test, from this simple calculation, right, that the voltage across resistor R1 without the diode is equal greater than 1 volt, it means that these two diodes are going to conduct, they are going to be in the on state, so the voltage across the resistor is going to be set by the two diodes, and the remaining part is going to go to the other resistor. Okay, so even if you calculated that this is over 1 volt, you're supposed to realize that these two diodes, when they're going to start to conduct, they're going to bring this voltage to around 1 volt. So that's why I wrote that VR1 is equal 1 volt. Okay, so next what we're supposed to do, we're supposed to simply realize that my output voltage, Vout, right, is going to be equal what? If the current goes in this direction, okay, because the diodes are conducting, we have I total, this voltage is much greater than 1 volt, so this current, right, my total current is going the same direction like the diodes are showing me, okay, the arrowheads of two diodes are pointed in the same direction like my I total, so the diodes are conducting. So I have positive sign over here, negative, because my current is going through this terminal and leaving at the cathode, and also over here positive, negative. So if you want to find output voltage, I'm going to use the way without the resistors first. So I'm going to see first negative VGE, negative VSI, plus voltage source. Okay, so this is going to give me Vout. So I have negative voltage across the germanium diode minus voltage across the silicon diode plus voltage source. This is equal negative 0.3 volts minus 0.7 volts plus 12 volts. Everything is equal 11 volts. Okay, so my output voltage is equal 11 volts. Next, I'm supposed to find the total current. Okay, why? I'll show you soon. I total, right, is equal to the current which goes through resistor R2. So I can say I total is equal IR2. Okay, total current is going to split into two currents, and it's going to come back together at this node, right? And it's going to go to resistor R2. That's why I'm saying that IR2 is equal to I total. So this is equal voltage across resistor R2 over the resistance R2, where voltage across resistor R2 is nothing else just the output voltage. Please notice that R2 is connected to the output terminal and ground. Okay, so voltage which will concentrate across this resistor is my VR2, but this is also equal Vout. That's why I'm going to write that this is equivalent to Vout over R2. We've found that Vout is equal 11 volts and R2 is equal 5.2 kiloohms. This is equal 2.11 milliamps. Okay, so this is the current I total. Next, we're supposed to find IR1. IR1 is equal VR1 over R1, where VR1 we said is going to be equal 1 volt because the diodes are going to set this voltage, over R1, which is equal 500 ohms. 1 divided by 500 ohms is equal 2 milliamps. Okay, so we've found the current which goes through resistor R1, and we found I total. You're supposed to realize that we talk about the parallel circuit, right? So the sum of these two currents, I mean current IR1, and I'm going to call this ID, is equal to I total. Okay, I'm going to write over here I total is equal IR1 plus ID. If my problem is asking me for the current which goes through the silicon and germanium diode, I'm supposed to realize that this is going to be the same current because these two diodes are in series, right? So I'm supposed to simply solve this formula for ID. So ID is equal I total minus IR1, where I total is equal 2.11 milliamps minus 2 milliamps. This is equal 110 microamps. Okay, so this is the current which will go through these two diodes. I can simply write that my ID is equal I silicon, this is also equal I germanium, and this is equal 110 microamps. Okay, so this is my current which goes through these two diodes. Next, we're supposed to find the power at the germanium diode. Okay, this is maximum forward power dissipation for germanium diodes. So we have I GE times VGE is equal to PGE, I'm supposed to write, right? So IGE we've found that is equal 110 microamps, right? So we have 110 microamps times 0.3 volts. So you can say that PGE is equal 33 microwatts. Okay, so this is the power at my germanium diode. Next, we're supposed to find PR2. Okay, let me write this over here. PR2 is equal I total raised to the second power times R2. So if PR2 is equal I total, and I total we found is equal 2.11 milliamps raised to the second power times R2, 5.2 kiloohms. So PR2 is equal 23.15 milliwatts. Okay, so this is the power at resistor R2. Next, we're supposed to find the total power. P total is equal I total times voltage source, where I total is equal 2.11 milliamps times voltage source, which is equal 12 volts. So P total is equal 25.32 milliwatts. Okay, and I can say that the problem is solved.